In this video, we will be discussing exponential growth. Exponential growth is an example of where you can apply exponents to some real-world examples. So exponential growth, there's a certain formula that we use for exponential growth. It's F equals I parenthesis 1 plus R raised to the T power. So let's start with F. F stands for the final amount. The final amount is usually the future amount. Most times that's what we're solving for, is the final amount. I stands for some initial amount that we're starting with. R stands for a rate, and they always give you a rate as a percentage. So in the formula, you have to take the percentage and convert it into a decimal. So remember, to do that, you just divide the percentage by 100 to get the decimal. And then T stands for the amount of time. So in word problems, there's exponential growth and then there's exponential decay, which is what we're going to be covering tomorrow. So you are going to need to know how to identify which types of word problems are which. So in word problems, you're going to look for some key words that represent exponential growth. So some of those key words that you'll see is the word increases or rises, gains, appreciates. So those are some of the more common words. Anything that means increase. Sometimes, another good one is pays. We'll add that to the list. And then you can also find whether or not an equation is exponential growth or decay by looking at an equation. In the equation, if the number inside of the parentheses is greater than 1, this would be an example of exponential growth. So let's say you have 1.01 in parentheses, that would be growth. But if you had something like 0.96, that would be decay. So that would not be an example. So let's apply this formula to an actual word problem example. So the problem says a new house costs $123,000. It is expected to appreciate 12% each year. Find the value of the house after 5 years. So the key vocab word here is appreciates. That's how I know it's exponential growth. So I'm going to use my exponential growth formula, which is F equals I parenthesis 1 plus R to the T power. And then we're going to assign our variables. So since it says find the value of the house after 5 years, that's a final amount or future amount. So we don't know what the final amount is. That's what we're solving for. So I'm going to put a question mark there. The initial amount is $123,000. The rate is 12%, but we need to convert that to a decimal. So 12 divided by 100 is 0.12. And then T is the time, which is 5 years. So now we're going to substitute all of those values into our equation. So you're going to have F equals 123,000 parenthesis 1 plus 0.12 to the 5th power. So the next blank says, what variable are you solving for? We're solving for F, which stands for the final amount. And then when you go to type this in your graphing calculator, you're always going to round to the nearest whole number except for money. If it's talking about money, then you round it to 2 decimal places. So since we're looking for the value of the house, we're talking about money. So we're going to round this answer to 2 decimal places. So let's grab our graphing calculators and we're going to type it in exactly as it's written. So I'm going to type in 123,000 parenthesis 1 plus 0.12, close the parenthesis, and then raise that to the 5th power. When I hit equals, I need to round it to 2 decimal places. So I'm going to look at the 0.02, and the number that's next to the 2 is a 7. So we need to round it up to 0.03. So going back to our notes, if I round our answer to 2 decimal places, I get $216,768.03. Now, since it's a word problem, we're always going to answer in a complete sentence. So I would say after 5 years, the house will be worth $216,768.03. Okay, let's practice this with a few more examples on the back page of the notes. So in example 2, it says Megan's parents have $10,000 to pay for college. They want to invest in a mutual fund with an 8.5% rate. How much will they have when she enters college in 4 years? So I'm going to define my variables, F, I, R, and T. We're looking for the final amount in 4 years. So again, that's our question mark. And then the initial amount is the 10,000. And then I'm going to do 8.5 and divide that by 100 to get the decimal rate, which is 0.085. And then 4 would be the T. So I'm going to use this equation, F equals 10,000, parenthesis 1 plus 0.085 to the 4th power. Again, we're talking about money, so we're going to round to 2 decimal places. So grab your calculator. I'm going to clear out the old equation, and I'm going to type in the new one, which is 10,000, parenthesis 1 plus 0.085, close the parentheses, and raise that to the 4th power. Now, when I hit equals and I want to round it to 2 decimal places, I see 0.58. The number next to the 8 is a 7, so I need to round that up to 0.59. So in a sentence, I would say, in 4 years, Megan's parents will have $13,858.59. All right, next one, example 3. A piece of equipment valued at $25,000 increases at a steady rate of 10% per year. What is the value of the equipment after 8 years? So again, I'm going to define my variables, F, I, R, and T. Since I'm looking for a final amount, that would be my question mark. The initial amount is $25,000. And then I'm going to divide 10% by 100 to get the decimal, which is 0.10. And T would be 8 years. So my equation is F equals 25,000, parenthesis 1 plus 0.10 to the 8th power. Again, since I'm talking about money, I'm going to round it to 2 decimal places in the graphing calculator. So I'm going to clear out my old equation. My new equation is 25,000, parenthesis 1 plus 0.10, close the parenthesis, and raise that to the 8th power. So if I'm rounding to 2 decimal places, I'm going to look at 0.72. The number next to the 2 is a 0, so I'm going to keep it at 0.72. So my answer in a sentence would be after 8 years, the equipment will be worth $53,589.72. Next example, this one's a little bit more challenging. In 1990, there were 43.2 million people who used free weights. Assuming the use of free weights increases 6% annually, write an equation for the number of people using free weights T years from 1990. Use your equation to predict the number of people using free weights in 2007. So again, I'm going to start off by defining my variables. So F, I, R, and T. I'm looking for a final or future amount, so that would be my question mark. The initial amount is a really big number. It's 43.2 million. So if you don't want to add all of the zeros, you can leave it as 43.2, but in your final answer, you just have to add the word million. The rate, I'm going to do 6 divided by 100 to get the rate as a decimal, which is 0.06. And then it doesn't give me t. It doesn't give me the time. So I have to figure out how many years have passed from 1990, which is the starting year, to 2007. So you can just subtract them to get 17 years as your time. So my equation would be F equals 43.2 parenthesis 1 plus 0.06 to the 17th power. Now, since we're talking about people, we're going to round to the nearest whole number in the calculator. So I'm going to type 43.2 parenthesis 1 plus 0.06 and then close the parenthesis to the 17th power. So if I round this to the nearest whole number, I'm just going to look at the number after the decimal point, which is a 3. And so I'm going to keep it as 116 instead of rounding up. Okay, so in a sentence, I would say in 2007, there were 116, and remember we got to add the word million because we left off all those zeros. So there were 116 million people using free weights. Okay, last example, example 5. Computer use around the world has risen 19% annually since 1980. If 18.9 million computers were used in 1980, write an equation for the number of computers in use for t years after 1980. Use your equation to predict the number of computers in 2010. So again, I'm going to do F-I-R-T. F is the future amount or final amount. And then again, the initial amount is a really large number. So we can abbreviate it as just 18.9, and then we're going to add the word million at the end. The rate, I have to do 19 divided by 100 to get the rate as a decimal, which is 0.19. And then I have to also find t. So this time the starting year is 1980, so I have to subtract that from 2010. So 2010 minus 1980, that would be 30 years. So in the calculator, you're going to type 18.9 parenthesis 1 plus 0.19 to the 30th power. And since we're talking about computers, we're going to round to the nearest whole number. So I'm going to go back to my calculator, clear out the old equation. I'm going to type in 18.9 parenthesis 1 plus 0.19. Close the parenthesis and raise that to the 30th power. When I hit enter, I'm going to look at the number next to the decimal point, which again is a 3. So I'm going to keep it as a 0 there. So if I go back here and I write it as a sentence, I would say in 2010, there were 3,490 million computers. So hopefully this is a fairly easy concept for you. You just have to know where to put each of your values. Feel free to reach out to your teacher if you have any additional questions about exponential growth.